An electric car is constantly deciding how much energy it can afford. When you're driving a gas car, the relationship is simple. You step on the gas pedal, explosions happen, and you move. But in an EV, every single acceleration is a complex negotiation between the motor, the battery, and a dedicated computer that acts as a high-stakes accountant. Your car isn't just moving, it's also calculating. It's measuring heat, chemistry, and physics in real time to make sure you don't end up stranded. Today, we're looking at the hidden brain of the electric vehicle and the system that manages the most precious resource on the road. Hey everyone, welcome back to the South Era Network. This is Tech Talks with Hasnan. Today, we're looking at under the frunk of the electric revolution. We aren't talking about charging or stations or politics. We're simply talking about pure engineering. How an EV manages its power, the genius of regenerative braking, and why your estimated range is the world's most sophisticated guess. In an internal combustion car, the fuel tank is just a bucket of liquid. However, in an electrical vehicle, the fuel tank is a living, breathing chemical factory. This is why every electric car has a BMS, a battery management system. Think of the BMS as the brain of the battery. An EV battery isn't one giant block. It's thousands of small individual cells wired together. The BMS monitors every single one of them. It checks their voltage, their health, and most importantly, their temperature. If you floor the accelerator, the motor demands a massive draw of current. The BMS then has to decide, can the battery provide that power safely? If the cells are too cold, the chemistry is sluggish, and pulling too much power could damage them. If they are too hot, they experience thermal runaway. The car doesn't just give you power, it allocates it based on the biological, like health of the battery at that exact millisecond. When you drive an EV, the motor is incredibly efficient, often over 90%. But the way you draw that power changes everything. This is where the physics of ohmic heating comes in. I hated physics when I was in college, but here I am making a video about Ohm's law. Crazy. When you ask for maximum power, electricity flows faster through the wires. This creates resistance, and resistance creates heat. That heat is wasted energy. This is why acceleration modes on your EVs lower your total range significantly. It's not just that you're moving faster, it's that the system is losing more energy to heat just to move electricity through the cables. The car's software is constantly balancing your request with the pedal with efficiency. In eco mode, the software simply smooths out your input, preventing those high heat spikes and forcing the battery to stay in most efficient discharge zone. The most counterintuitive part of EV power management is that the car can actually unspend its energy. This is called regenerative braking. In a normal car, when you hit the brakes, you are using friction to turn your kinetic energy, movement, into heat, which is then wasted into thin air. In an EV, however, when you lift your foot off the pedal, the system reverses the roles. The electric motor stops being a motor and starts being a generator. The wheels use their momentum to spin the motor, which pushes back electricity into the battery. The BMS has to manage this perfectly. If the battery is already at 100%, it can't accept more power. This is why your regen often feels weaker when you first leave your house with a full charge on your car. This is when the car has to decide, do I put this energy in the battery or do I have to waste it through the traditional brakes? It's honestly a constant invisible juggling act of energy. We've all heard of the guessometer, the range display that says you have 200 miles, then 150, then 180. This happens because the car is adapting to external physics that you might not even notice. The first one is aerodynamic drag. Air is thicker than we realize. Moving a car at 70 mph requires significantly more energy than moving it at, let's say, 50. The car's computer is measuring the wind resistance and adjusting your range in real time. The second one is HVAC systems. Unlike a gas car car that uses waste heat from the engine to keep you warm, an EV has to create heat. Using a heater is a direct draw from battery. The car knows exactly how many kilowatts the AC is pulling and subtracts that from your driving distance. The third one is terrain. The car's GPS and accelerometers know if you're climbing a mountain or sliding down a slope. It knows that gravity is now a power draw and adjusts your estimate before you even reach the summit or the ground. Now let's talk about how this coordination of hardware and software is happening. An EV is essentially a rolling computer network. The inverter is the bridge between the battery, which uses DC power, and the motor, which often uses AC power. The inverter switches the power on and off thousands of times per second. By changing the frequency of these pulses, the software controls the speed and torque of the car. This level of coordination allows for things that gas cars often struggle with, like instant traction control, for example. An EV can detect a wheel slipping and cut power to that specific wheel in milliseconds. This is far faster than any mechanical clutch or gear could ever dream of. But there's one more trick the thinking battery has up its sleeve, something called preconditioning. Have you ever noticed your car using more power on the way to a fast charger? That is not a bug. If the BMS knows you're heading to a high-speed plug via the GPS, it intentionally starts wasting energy to generate heat. It's essentially trying to stretch its muscles before a sprint, and that helps your car charge faster when it finally reaches the charging station. The power management isn't just about moving the car, it's also about micromanaging the physics of every single tire on the road. From consuming to managing driving an EV requires a shift in how we think about fuel. We are moving from a world of consumption to a world of management. In a gas car, the energy is spent and gone. In an EV, that energy is part of a circular system. You manage your heat, you manage your momentum, and you manage your chemistry. The car is your partner in this, which does the complex math so that you don't have to. Understanding this will simply make you realize that the magic of electric car isn't the battery. It's the software that knows exactly how to use it. We aren't just driving batteries anymore, we are driving intelligence. And that's it for today's video. Do you think that the estimated range on your dash is a helpful tool, or is it a source of anxiety to you? Let me know your thoughts in the comments down below, and if you like this video, make sure to press that subscribe button and also hit that bell icon so you get notified of our upcoming content. As always, thank you so much for watching this video. I will see you in the next one.